Yo, how's it going, guys? Yo, how's it going? Hello, hello. Afternoon, everyone. What are we doing? Where the hell is the remote input terminal on this thing? Oh, it's way around the other side. Okay. Not a huge fan of these things, no. They have the right idea, but the implementation is not great on these. Had the potential to be pretty nice, but right, let's have a look at then. See why this is in the workshop, shall we? Okay, so we know there's no dead power supply FETs in this. We have we have good switching. Oh wait, what's wrong? What's going on with my scope cam? It's not showing up. One sec. Scope cam. Deactivate, reactivate. There we go. Power supply cam as well needs updating. Nice colours for some reason on this camera. There we go. Okay, cool. Now all the cameras are working. Good to know. Right. So let's power this up and see why it's here in the workshop. I think the guy said that this either goes to protect or it just doesn't power up. I've checked that this doesn't have any dead output MOSFETs, so let's see what it's doing here in the workshop. Okay, so we have 0.8 amps worth of IR with a current draw. We have the blue light, power light is on, and it's not going to protect by the looks of it. But I'm not seeing any signs of switching. Oh, a little bit there perhaps. Let's have a look. Oh no. Okay, so no signs of Class D switching from any of these outputs. Okay. Negative rail. That's the drain of one of these. Okay, so yeah, we've got no output switching. So what it usually tends to be in these amplifiers is these are using an IRS2093M, which is just this little bad boy right here. And throughout the heat and cool cycles that this goes through, the solder actually starts to crack a little bit on the underside. And so usually all we need to do with these ones to get them back up and running again is just to reflow this IC. So that's what we're going to do today, first of all, see if that's the problem. So just a little bit of flux around the edge here. Now there's two ways that I can do this. I can either reflow it with a hot air gun and yeah, just like use the hot air station to reflow it, or I could use the iron, the soldering iron, and just run the tip along the edges, which would melt the solder along all of the pins and sort of solder it. But I think I'm going to use the hot air gun today on this one, maybe. Yeah, I think we shall hot air it, although it is a little bit tricky. You've got these capacitors here, so I don't really want to be melting any of the plastic on those caps, so maybe we'll start off by going around it with the iron. Yeah, maybe we'll do that first. So before I touch my iron on this board, I want to make sure that the rail voltage is no longer present in here. No, it looks okay. Don't seem to have any voltage left in the board. Good, good. So yeah, I'm just going to get my iron not too hot and just a little bit of flux around the chip. I'm just going to go around the edge. And that should reflow these pins. How close can we get with this camera? Just like that, you see. It's actually so close to these caps that it's actually quite difficult to even get the iron in. Okay, let's give that a clean up with the isopropyl and see if that was enough. See if we reflowed whichever bad pins were causing there to be a disconnect. Now, I want to make sure that I haven't made any solder bridges while doing that, so I'm just going to take the microscope real quick and just have a quick look, make sure that there's no solder bridges by that chip now. Okay, looks good so far. Looks good. Looks good on that side. And yeah, looks good on that side. I'd say that that's good. So let's power it up and just see if that was the only issue. Okay, so we have the same issue. No Class D switching. Now, that's the most common problem with these amplifiers. It might still be, I might just need to reflow it with the hot air gun. One thing I'm going to do actually is just turn the amplifier off, and I'm going to push down on the chip quite hard with my hand, just in case there's like a bad solder connection over there, and I'll make it better by pushing down on it. Nope, doesn't make a difference. So next thing you want to do is check that this chip is actually getting all of the required supply voltages. So we have a couple of voltage regulators here on the board, a couple here, one over here. So oh, it actually looks like we've got 10 volts on the heatsink. That's a bit unusual. 12 volts on the heatsink. Okay, that's a bit unusual. Why would there be 12 volts on the heatsink? Does this amplifier have a heatsink ground? I think it does. I think it should do. Yeah, I don't think that having 12 volts on the heatsink is an issue. Let's see whether the voltage on the heatsink has any real current behind it. So I'm just going to short out the heatsink real quick and just see whether I get a spark. No, I don't seem to get a spark. Okay. So I don't think it's got any real current behind it. Yeah, it just disappears instantly. Slowly rises back up again. So I don't think that's an issue. Not sure what could be causing that. But I don't think that's an issue. So let's check all of the supply voltages then. First thing, let's have a look on the preamplifier board. I want to check that there is plus minus VCC going to the op amps and the preamps. So there are some TL074Cs. So we've got plus 13 and minus 10. It's a little bit uneven, but it is there. It shouldn't really be causing this to not turn on and function. Okay, this is a 7905. So this should have negative this should have negative 5 volts on it. We have negative 3.6. That's not very much, is it? Got 10 volts going in. This one over here is a 7805. So that has 6.3 volts coming out and 13 volts going in. I think maybe my output side ground reference is just a little bit off. So I'm going to go ahead and tie a ground to the output side ground. Just by sticking something in one of these holes here. So output side ground is speaker negative terminal. So I'm just going to shove an Allen key in there and then clip my oscilloscope ground to that, which will couple my oscilloscope to the output side ground of this amplifier, just so we get more accurate readings on the scope screen here. So there you go. Now I've got an output side ground reference. Let's measure the parts in the preamp again. Okay, there's negative 5 and positive 5. Looks fine to me. Okay, let's check some of the other parts over here. So we've got a couple of other regulators over here, probably going to be plus minus 15. There is. Okay, that's 12 volts, 12.1 coming out of that one. And 12 volts coming out of that one. And this one should be 12 volts reference to negative rail. So negative 24, negative 35, 26. Okay, so it looks like all of the supply voltages are actually there and present. Oh, hang on a minute, this inductor feels a bit wobbly here. I wonder if that's come loose from the board. Feels a little bit loose, that one. Okay, I don't think that's the issue. So I'm going to try reflowing the 2093M properly with the hot air gun. Doing it with the iron didn't make much of a difference, but that's the most common issue in these. So I'm just going to try it with the hot air gun to see if that works. If not, then it might need a new 2093M. So I don't want super high air pressure at the moment for this. Yes, in answer to your question, NUEN, you absolutely should be buying Class D for bass, because for subwoofer application, it's like the differences in amplifier topology are not going to be translated through your subwoofer at all. So yes, you should be using the most efficient Class D amplifier you can for your subwoofer setup. Leave the Class AB for your mids and highs where the differences are actually transparent. So I'm just going to preheat the board a little bit around the area, because these can blister. The PCBs can blister quite easily if you've got one super hot spot and the rest of the board is pretty cold. So I'm just going to preheat the rest of the board around the area just to prevent it from blistering. Okay, that should be enough. So now I'm just going to start heating the IC. I'm just going to wait for the solder to melt, and then I'm just going to shift it over on its legs a little bit, just to prove that it has reflowed. Okay, that should be good. So wait for that to cool down and we'll test it again. So this is a 6-channel amplifier, I think. Yep, 6 channels. So we have our 4 main channels for mids and highs run by this 2093M, and that's these 4 channels here. You've got 4 MOSFETs, and these MOSFETs are dual N channel MOSFETs. So you've got a high side and a low side in the same TO220 package. 1 MOSFET for each channel. Little output inductor here, which is pretty cute. This one is very loose and it's doing me a bit of a worry, but we'll see how that goes. And then the channels 5 and 6, which will be designed more to run subwoofers, are run by these MOSFETs over here on the heatsink. We've got some TO220 MOSFET single N channel FETs, 1 high side, 1 low side for channel 5, 1 high side, 1 low side for channel 6, and those are run with IRS2092s. So different drivers to the full range 4 channels for the front and rears. Okay, that should have cooled down sufficiently now for us to power it up again and see what she's saying now. Let's probe the output of one of these. Actually, no. Yeah, there we go. I can remove that bit of gunk there. Access the inductor a lot easier. Yeah, the transformer looks kind of big on here, but it's actually pretty small. This is a pretty small amplifier, so it's not actually that big. Like, look how tiny these inductors are compared to my little finger. Very small. I'm just beefing up the solder joints on this little inductor here, just because it seems a little bit loose, just before there's any chance of any kind of fatigue to the metal. Just bolstering up the solder joints a little bit. There we go. That's much more sturdy now. Okay, let's give it some power and see if it wants to give us some Class D switching now. Okay, so still nothing. We're not got anything from in any of the front 4 channels. Let's have a look at the sub channel here. No switching from the sub channel either. Ah, hang on. Whoa. Okay, I think I understand the issue here. Seems like we might actually have dead MOSFETs in the sub channel that I had missed. I can't remember if I checked these ones last night, so I think it's going to be just dead FETs in the sub channel. Let's have a look. So these are IOFB 31N20s. And these are quite fast, quite quick MOSFETs. And that will be because the switching frequency will be quite high, because I assume that you can use channels 5 and 6 for either subwoofer application or full range application on this amplifier. So we have some pretty fast switching MOSFETs to allow you flexibility in how you want to use it. So let's get the multimeter and see whether we do actually have dead FET on the sub-channel here, the 5 and 6. Okay, 512, 471. There we go. There's our short. 55 ohms there, by the looks of it, on the multimeter between drain and source. So yeah, there's our issue. Hadn't spotted that earlier for some reason. I think I forgot that this was a 6-channel. So let's get the amplifier out of the heatsink, and that will allow us to do a few things. Firstly, it will allow us to push this inductor that's a bit loose further down onto the board, giving it a bit more stability, but also allow us to change the FETs in the output section, channels 5 and 6 here. Ubisoft, I have no idea what that could be, unfortunately. That's a very strange issue. Could be a fault with the crossover. Sounds like you're using some kind of external like EQ or crossover device. You don't need to use those anymore. Head units have come such a long way and have all of those features built in, unless you're using maybe factory head unit or something and you're wanting to get some kind of low pass filter to the sub, but then the amplifiers have that built in anyway. There's not really any reason in today's day and age that you'd need to use a passive external crossover EQ unit. They're very, very outdated. Either the head unit has the settings you need, the amplifier has the settings you need, or if you really need massive complexity in EQ and crossover settings per channel, then you get a DSP. Simple as that. How's it going, Boris? What's up, my man? Ubisoft says it's a 4-channel amp. It does it only on high pass, so it moves the speaker very deep at something like 2 to 10 hertz. So do you mean that the speaker continues moving the whole time, or does it only move while you're adjusting the knob? So if you move the knob, the speaker moves in and out. But then when you stop moving the knob, does the speaker stay still, or does it carry on moving even when you're not touching it? Hey, what's going on, Sine Wave? How's it going, my man? These little amps are pretty cool, I have to admit. There's a lot of power tucked into a tiny package here. They are pretty cool little things. he said, yeah, speaker continuously moves when I stop rotating the knob, and even if there's no music running, it will still continue to push the speaker like frequency generator would do. So it sounds to me like a preamplifier fault. So if it only does it on high pass filter mode or something like that, saying, let me just read what you said. You said it only does it on, it does it, it's a 4-channel amp, it does only on high pass. So it sounds to me like a preamplifier fault. I suspect that one of the op amps in the preamplifier circuit has gone faulty, started leaking. And yeah, the oscillation is just as a result of current draw, and then the voltage drooping as a result of the current draw, which then allows the voltage to rise back up again, and then the current draw begins again in like a cycle. So I think that's what you're experiencing. So yeah, you'd need to diagnose that, replace the op amps in the preamp circuit that are faulty and giving that issue. Guys, give me a shout out in the live chat if you're currently watching from the UK. If you're in the UK, give me a shout. Just want to see how many guys we've got from the UK here right now. I've got 2 Hertz amps I'm fixing right now. Unable to probe the 2092S drivers, so I just changed them. Why can't you probe them? Are they difficult to get to in an awkward location? Yo, quite a few guys from the UK. So, does anyone remember, I had some videos a while ago on the Digital Designs 700 Series 12s, a long time ago. These are the slightly older versions. If anyone remembers the Digital Designs 700 Series 12s, or the 15s actually in that respect, with the red stitching, did some cool videos of that. I've got a nice video on my channel actually of one of my friends at the time, had a pair of those subs in a Skoda Fabia, on an LW audio at 0.5, freaking loud, really nice subs. If anybody remembers those subs, I was selling those for a while. Hey, I'll get a picture up. Just want to talk about this for a sec. Let's just get a picture of the ones up that I'm referencing here. And Google just seems to only have the new ones, right? There we go. These are the ones. So who remembers these? So these are fantastic subs. I was selling these in the UK for quite some time. Okay. And I was selling them for £280. As a result of the recent nonsense after Brexit and stuff, they're now selling for this much money. It's absolutely insane. I think it's a bit of a rip-off, to be honest. However, if you're in the UK and you still wanted to get one of these, they're absolutely incredible. They're actually, believe it or not, absolutely identical to the In-Phase power drive. Now you might think In-Phase is not the brand that you would usually turn your head to or look towards. But check this out. In-Phase power drive. Okay, well, let's just go to Car Audio Center for a second. The first result on here. Let's just see how much they're selling it for. 400. Okay, that's a bit more than I thought. I thought that they were much cheaper than the DD versions. I seem to remember them being much cheaper. Unless I guess the price has gone absolutely insane on these. There's a website here that's got them, well, it says limited stock for $189. I'm a bit confused at the pricing, but anyway, my point is that if you're in the UK and you wanted to give one of the Power Drive 12s a go, aka Digital Design 712, one of my guys is actually giving one away for free. So if you want to be within a chance of getting that, if you're in the UK and you want to have a play around with a DD712 or the power drive version of that, then there's actually a giveaway for one of those, so you can grab one. Sinewave, give me the details in the live chat right now because I can't look at what the details are, but the guy doing the giveaway is Sinewave here in the live chat, so big up to Sinewave. He's giving away one of these subs, so drop the links and all that in the live chat, my man. And because you're watching my stream as well, you have the ability to get some extra entries as well into the giveaway by entering a special code. So hopefully Soundwave will see that and drop the details in a minute. We just wanted to give him a shout out on that because I think it's a really cool opportunity because they're fantastic subs, and usually they're cheaper than the DD versions, but obviously if there's a chance you can get one for free, then you might as well give it a go. Right, let's see about this MOSFET then. So this has 2 channels for this kind of rear. So channels 5 and 6, obviously 2 channels. So we've got one MOSFET for high side, one for low side, one for high, one for low. Now it seems that we've only got one dead FET over here, but it would make sense to change at least both of these ones in this channel, maybe even all 4. We'll see what I've got spare, see what I've got in stock. But the repair would be to replace the FETs in the dead channel, but it might be a good practice just to change all 4 of them anyway, seeing as, you know, there's only these 2 here. It's only 2 FETs, isn't it? It's not really going to add a drastic amount of extra cost. So I'll replace the bad channel first and just see if that gets it up and running, and I'll see what parts I've got in stock. I don't know if the 31N20s are actually still made, so I might have to use some substitutes, and they need to be quick. They need to be fast MOSFETs because the switching frequency on these is quite high because they need to be able to play full range audio as well as just subwoofer frequencies. How's it going, Matt from Denver? How's it going? Ubisoft is from India. How's it going? He said, do you have a website? Do you sell any stuff? I don't have a website and I don't sell any stuff. I just offer a repair service and that's it. I did used to stock and sell digital design subs for a while. I never had a website. I just did it through word of mouth. But I've kind of stepped away from DD now. So yeah, I don't really stock or sell anything anymore. Just offer a repair service, and I'm trying to boost my content a little bit on YouTube with the boom or bust. Trying to get that popping off, you know. It's hot as fuck here. Nice. I kind of wish it was a bit warmer here. It's springtime now in the UK, but it's not really that warm yet. It's still really freezing. Is anyone enjoying Boom or Bust? How's it going? You enjoying it? Is it good? Got any suggestions? Let's chat about Boom or Bust if you've got any ideas or suggestions. Anything you want to suggest or say about Boom or Bust? Now's the time. Man, that Tuba HT was freaking massive, hey? I actually wanted to do a few more things with the tuba. I was curious to see, because when I did the DB testing, I obviously had the Tuba HT firing to the back of the cabin. One thing that I wanted to do, actually, which I didn't, was try it firing forwards, because the actual mouth of the enclosure, the box, for the Tuba HT was quite close to the sensor. Now, I would consider that cheating a little bit. Like, if someone designs a box where the port is, like, right by the sensor, I consider that cheating a little bit. So I didn't want to do that. I wanted to load the tuba off of the back of the test cabin. But I'm kind of curious to see what it would sound like if we turned it around and fired it at the sensor and see how loud it got. Right, what I need, 31N20s. Let's have a look. 200 volt 220s. 250, 200. Okay, these are 150 volt FETs. Here we go. So let's see, do I have any 31N20s hanging around in here? Okay, there we go, there's one. There's another one. (23N20). Well, that's not one that I am familiar with. Yeah, the tuber is good. The problem with the tuber is it's so big though, isn't it? Like, I think the point of Boom or Bust, one of the points for Boom or Bust for me, was to allow you guys to consider what sort of enclosures you wanted to build for yourself, for your own setups. And obviously the loudest one would usually be the one that you want to build, but the thing I didn't really take into account was the fact that some of these enclosures are going to be so big that it doesn't really make sense to build them. Like, yeah, the Tuber HT is the loudest box so far by quite a long shot, but I don't think it's the most sensible one for you to build if you've got a single 12. Hell no. So I definitely need to kind of figure out some kind of formula to take into consideration the physical size of the enclosures. So I might need to consult somebody who's good at the old maths, quick maths, and some like formulas and equations. I want to make it fair. I want a kind of equation or a way to calculate for the enclosure size relative to its performance. Yeah, okay, I think I found all the 31N20s that I had laying around in here. Yep, that's probably all of them. Okay, so let's just have a quick read of some of the specs of the original FETs that came out of this amplifier. One of them's dead, of course. I want to match them with the other channel if I can. That one's toast. That's the dead one. Ah, now these FETs seem to have such a high VT that my meter here, my reader, doesn't actually read them. Yeah, it just reads them as a diode between 2, 3. So the VT must be over 5 volts. Same for that one. 3. That one's actually dead. VT is the MOSFET the gate turn on voltage. So obviously the gate of the MOSFET requires some voltage on it in order for the FET to turn on. And the VT is the specification that tells you how much voltage is required to be on the gate in order for the MOSFET to switch on fully. So MOSFETs with a lower VT will turn on sooner given a specific drive wave, and MOSFETs with a higher VT will turn on a bit later. It doesn't really mean anything in terms of like MOSFET selection as such, provided you've got enough gate voltage or from your drive circuit to, you know, turn the MOSFETs on. Most drive circuits will send about 12 volts peak to peak to the gate, so yeah, you're going to be fine. Whether it's 4 volts or 5 volts or 3 volts, it's fine. But what's important is that you match up the VT of MOSFETs that are in parallel with each other or in the same, you know, output section bank as each other. Because if you've got one MOSFET turns on way before another, then for that brief moment that one's on and the other's off, you get cross conduction, and that will just cause the MOSFETs to get hot and eventually fail. Alright, I think the driver is probably okay. We didn't actually have a short, a very low resistance short between gate and source or gate and drain. So the short was only between drain and source, so that leads me to believe that it's going to be, drive circuit's going to have been completely unaffected by this. How much power do we lose by going from 14.4 to 12 volts? You can figure that out yourself. All you've got to do is use square law correction factor. So, take a calculator, okay? Let's say that your amplifier does 1000 watts RMS into 14.4 volts. So you've got 1000 watts RMS into 14.4. Now if you're going down to 12 volts, what you need to do is you need to do 12 volts divided by 14.4, square the result, and then times this. This is now your correction factor. Times that by your power. So you would lose about 300 watts. You get about 700 watts now at 12 volts. So it's really easy. If you ever want to, and this actually works, this is accurate because it's based solely on the transformer primary and secondary ratios and the rail voltages that will be present as a result of the input voltage. Yeah, it's just square law correction. Really accurate. So let's say that you're running your car, your amplifier is rated to do 5000 watts into 14.4 volts. Let's say you're dropping to 13.2, right? So what you do is you take your voltage that you're dropping to first, 13.2, divide that by the voltage that has a known power rating. So 14.4, you know that it's rated for 5k at 14.4, but you don't know what it's rated at 13.2. And then you square this to get you your square law correction factor, 0.84. And then you times that by the 5k that you know was at 14.4, and you get 4200 watts at 13.2 volts. You can do the same the other way around. Let's say, for example, the Sundown Salt. Let's say one of their amplifiers is rated for 4000 watts at 12 volts, and you want to see what would that be equivalent to. How do I compare that to an amplifier that's got its ratings made at 14.4? Well, you would take your target voltage being 14.4 volts, divide that by the known power voltage, 12 volts, square the result. So your correction factor in this case is a nice number, 1.44, and you times that correction factor by 4000. So the Salt 4000, for example, makes about 5700 watts at 14.4. That's how you compare amplifiers that have their ratings made at different voltage levels. The only time that doesn't ring true and doesn't hold true is if your amplifier has a regulated power supply. If the power supply section is regulated so that it maintains a consistent rail voltage regardless of whether you're putting 12, 14 volts in. Obviously that won't work, but for the you know, for 99% of car audio amplifiers coming out of China and Korea, this does work. Alright, so we've replaced the 2 output MOSFETs in the bad channel on this amp. Let's throw some power wires in then and see whether it starts switching and works now. We want ground in that one, because that's our ground trace. How do you get 15.8 volts to your amp? Generally it's not a good idea unless you're running batteries that can support that much voltage, and you also need to make sure that your amplifier can actually run safely at those voltages. Some amplifiers are rated up to 16 volts. However, what they don't tell you is that at those higher input voltages, the rails inside the amplifier are so close to the breakdown limits, the voltage breakdown limits of the MOSFETs inside, that the amplifiers are highly unreliable when ran that high. If you're going to run your amplifier at close to 16 volts, 15.8, I would say you want your amplifier to be 18 volts stable, not 16 volts. You don't ever really want to be running the amplifier within a couple of tenths of a volt away from its limit. It's not going to be too great. But the thing is, guys, power these days is cheap. Power is cheap. You can get 10 kilowatts for under £1,000. Power is cheap. There's no need anymore to be running your amplifiers up at 16 and 18 volts and all that nonsense. Unless you're competing and your competitor is like 0.2 of a dB ahead of you and you need every last tiny 0.1 of a dB out of your system that you can get, sure. But if you're just daily driving and street basing, nah, man, run it at 14 volts, man. Alright, cool. So let's see if this gives us some Class D switching now. Okay, rail voltage is present. Nice, nice. Oh, hey, there we go. Got Class D switching on both channels of our sub. And let's just check we've got Class D switching from our 4-channel front stage. Boom. Yeah, love to see it. Excellent stuff. That's a wrap for this amplifier. So it's just a dead FET in the output section. Nice and easy. Super easy. That's probably about as easy as it can get. I thought car amplifiers never had built-in regulators, so some amplifiers do, yeah. For example, the most famous ones are the JL Audio the JL Audio Slash series, the Slash 500, 1000, yeah, many of those are regulated. A lot of the Alpines are also regulated. The PDX amplifiers, I think, are regulated. To an extent, you've also got some of the Brazilians now are sort of regulated. There's some rudimentary regulation that goes on with the some of the newer full bridge amps that are coming out. And what they'll do is they'll just turn the power supply section off. Right, so the amplifier you'll be turning on. And let's say you're running the amplifier at 12 volts. The power supply section's running and supplying rail voltage to the output section. And then when you increase the voltage up to say 14 volts, there'll become a point where the output rail gets dangerously high. There's a circuit that detects that, and when it gets to its certain threshold, the power supply section in the amp will actually turn off. And then the power supply section turns off, which causes the rail voltage to sag down a little bit. And then once the bottom threshold is reached for the sagging, the power supply turns back on again, boosts it up a little bit. So the power supply will be switching on and off, maybe like, I don't know, 1,000 times a second. but it's doing so quickly that it's just maintaining the rail voltage underneath the threshold for being too dangerous as far as the amplifier is concerned. Then obviously when you draw current from the amplifier, you play a bass tone, all the power goes to your sub. That causes the rail voltage to sag down because you're pulling current from it. So the rail voltage sags down, therefore the power supply remains on even though you might be holding 14 volts because the rail voltage is now sagged down. So regulator amplifiers don't suffer from lack of power as a result of that mechanic. It's just to prevent the rail voltage from creeping up to dangerous levels when it's idling. Yo, Mike Honda, thanks for the $20, my friend. That's really kind of you, buddy. Good morning, Sam. Getting back on the road, heading to Tahala, say. I don't know why I had to say that. Both of you and Todd should do a collaboration on that Orion he has. Todd. I can't remember who Todd is. Sorry, Todd. I'll have to check that out. Maybe someone killed. Maybe Todd killed an Orion amp. If that's the case, then I will maybe do a collab. Who knows? Can you explain why we don't see switching on every FET, rail voltage on half of them? Yeah, exactly. That is because some of the FETs are high side and some of them are low side. So all of the MOSFETs are actually switching, but the switch wave that you see doesn't occur on the same pin of every FET. So on the low side FETs, you see the switching on the drain pin. On the high side FETs, you see the switching on the source pin. So all the MOSFETs are switching on and off together, kind of opposite from each other in like a seesaw fashion. But when you're probing the back of the FET, which is tied to pin 2, you only see it on the low side ones. So yeah, there you go. Hopefully that answered the question. Is it a good idea to use a car amp in home to power up your bookshelf speakers? Nah. Reason being is that when you're using a car amp indoors, you're converting voltages way too many times unnecessarily. It's very inefficient. You're taking mains voltage and then you're having to convert that down to 12 volts, which is very inefficient, and due to the low voltage, high current, there's a lot of loss that can happen along the cabling. Then you're taking that 12 volts and the amplifier converts it back up again into some higher voltage for the amplifier section to use. It's a very inefficient way of doing it. So no, don't do that. If you want to run bookshelf speakers, 50 watts is plenty loud enough for anything you'd want to run on bookshelf speakers indoors. A home audio amplifier, something from Technics, Pioneer, Rotel, Cambridge Audio, just any like decent enough home hi-fi amplifier is going to be absolutely fine. You don't need to run big power indoors and don't need to use car amps for that. For running subwoofers indoors, you can use PA amplifiers, which are great. You would need a preamp for that though, usually. But PA amplifiers for subs, and yeah, just some nice Class A, Class AB integrated amplifiers for mids and highs. That's all you need. Oh, it's me, Sam. Todd, yo! Sorry, man. I'm not honestly terrible with names, like actual names. Like, I know you as eBerg Amplifier Repair generally. I have a 5K that's been here since the first of the year. What's up with it? Is it you can't get parts for it, or is it just giving you a massive headache? Yeah, give me a shout on Bevid's Facebook page if you haven't already. We might already be discussing it. My brain sucks with this sort of thing. J Brown, sundown, stuck in protect mode, change the output FETs and pray that the drive circuit's okay. Changing the output FETs is doable for a beginner / amateur technician, if you want to give it a go repairing it. Change the output FETs for, in that one, you probably want to use IRFB 4115s. Change all 4 of those and see what happens. If it works, great. If it doesn't, drive circuit's probably dead, in which case you need to do some surface mount reflow work with the drive IC. I have an amp with these FETs, it says they're obsolete. Just drop in some IRF 3205s, man. That's cool. They're power supply FETs. Power supply are not fussy with what FETs you use. Generally, any decent high current FET between 40, 80 volts with similar current ratings to the originals and similar. Well, even the speeds aren't even that important because the switching frequencies are so low. But yeah, just check some data sheets for some FETs if you want. But if you're unsure, just use some IRF 3205s or some 65 NF06 or just anything similar. Be absolutely fine. So what happened to the Taramps 800x4? I just haven't got the parts from Taramps yet. They asked me to put an order in, but I haven't actually put the order in yet. So when you check for output switching, you clamped your ground to the amp. I just clamped it to one of the speaker negative terminals. Make sure it's not a bridge terminal. Make sure it's an actual true output side ground. So generally, I won't say this for sure in every amplifier, but 99% of amplifiers, even if they've got a bridge mode, the left speaker negative will be a true ground. So if you're ever unsure, you could probably ground to left speaker negative, and that will almost certainly always be a true ground. Right speaker negative can often sometimes be an inverted positive, so if you ground your probe to that, you're going to kill the amplifier. Yeah, so let's get this back in the case. We are good to go with this one. I can move on to something else. I got some interesting ass repairs lined up, possibly for today. Depends how it goes. Not an amplifier, interestingly. One of the repairs I've got lined up is not an amplifier per se. It's a processor. I'm not looking forward to it, but we can look at it together. It could be an adventure. Do you work on the first gen US amps? Yeah, I'd work on those. There's not really many in the UK though, so typically I won't really come across them. Why does a 4-channel have a bass knob? It's probably because the amplifier manufacturers, designers, assumed that some people might want to use channels 3 and 4 for powering a subwoofer. So the bass knob will most likely control either the gain or the kind of like level relative to the set gain position for channels 3 and 4, or in some cases it could actually be like a bass boost knob that's tied to channels 3 and 4. Hello from across the pond, how's it going, Rick? Thanks for jumping on. I have a 12-inch DVC 4 ohm and a 12-inch SVC 4 ohm, and my amp has a 4 ohm impedance on bridge mode. What do? You can't use those subs together, my friend. It's a big bad idea to use different subs together in the same system, because it can work, but generally you're going to have the subs with different delays, different sort of phase response at different frequencies, and they will cancel each other at specific frequencies. The sound might be very muddy, uncontrolled. Yeah, just not a good idea. Use one or the other. I would say out of those two, you're probably going to want to use the dual voice coil one, which I assume will be more powerful. So you don't want to be using two different subs at all on the same system, and certainly not on the same amplifier. So if your amp has a 4 ohm impedance on bridge mode, then you want to use well, actually no, yeah, you've actually only got one choice. If your amplifier is 4 ohm stable bridged, then you would want to use the SVC subwoofer bridged across those channels. You can't use the DVC because that will be either a 2 ohm, which would be too low, or it would be an 8 ohm, which would be pointless and you wouldn't be getting enough power out of the amplifier. Crew chief, I would keep the Rockford. Reason being, you don't need that much power on your mids and highs, unless you are doing a kind of sound clash build, a big PA build where your intention is to open up all the doors or have the speakers externally and play across a large area to a crowd outside of the vehicle. For inside listening in the cabin, you don't need that much power. People buying all these 4-channel amplifiers and these mids and highs stuff with like stupid power ratings, I guarantee you don't need that much power. The only time you would ever need more power on your mids and highs is if you, for whatever reason in your specific application, are reaching the clip point of the amplifiers at full range, which you'll know about because you'll hear it instantly. It will sound horrible and distorted. So if your amplifiers are distorting and clipping at full range in your application and you need to go louder still, then yeah, sure, upgrade your amplifiers. Upgrade your amplifiers for your mids and highs to something more powerful. But I guarantee that if you're listening in the cabin, you don't need that. Don't need that in the slightest. I have, obviously my van has the 2DDZ 415s. Last time I metered that, it was a 156 at 25 Hertz. And on my mids and highs, I have, I think it's like 65 watts per channel. And it keeps up with the bass at full chat. You don't need that much power in your cabin. I do not need the extra power. Not now. Would I like it? Yes, but why would you like to have the extra power sitting there doing nothing? Like, I mean, okay, having headroom is good for sure, especially in subwoofer application, but for your mids and highs, so much of that power is going to be headroom. You're not going to be even tapping into 10% of that. And you've downgraded on the actual quality of the amplifier, the sound quality, by going from the Rockford to the JP. So it's a no-brainer for me. Keep the Rockford. Coming from a PA background, I love the way most speakers sound properly driven. With clean power you get power compression before distortion. And also, things sound better up loud. That's just how the human ear works. What's going on with this one? Does that go... Oh, that's going across there. What the heck? Okay. John Henry, first time live, but I always watch your videos. Thanks very much, John. Appreciate that. Thanks for jumping on the live. It's a bit of a different experience. My man says, do you know anything about the So and Vega subs? I don't personally know. I haven't really had much experience at all with So and Vega. The only thing I know obviously is that the dual suspension system, it allowed you to change the mechanical compliance to your liking depending on your application. So you could stiffen up the woofer or soften up the woofer depending on what you were doing with it and what kind of enclosure and frequencies you wanted to play. So that made it pretty cool. I know that in recent years they have still released subwoofers with the dual spider setup. I don't know if it's been adjustable like it was back in the day though. I think it might just be like cosmetic, not, yeah, kind of like a cosmetic thing as a nod to the past. I don't know whether it's actually tunable still, but I could be wrong because I don't really follow it. Where in the UK are you at? Just in the UK. UK is pretty small, so if I say the UK, it's only a certain amount of land mass. Hello from Texas. How's it going, Daniel Watts? How's it going, buddy? Yeah, the Stroker was really cool for its time. Definitely. John says he's coming in the next few weeks. Nice, man. You're gonna like it, I think. Depends on where you're going, but yeah, UK has some absolutely beautiful sights to see, man, and a ridiculous amount of history as well. It's pretty insane. Yeah, the land mass of the UK is very small, but the population density is very high. So yeah, the UK might seem small in size, but holy hell, it is dense. I found that out when I visited Oklahoma and Dallas. Yeah, big countries, but in Oklahoma you can't just walk out of your house and walk to the shop. Like, no, you've got to get in your car and go everywhere. And everything is made massive purely for the sake of making it massive because there's so much land you can just fill up, man. Car parks are ridiculously oversized. I have been to America. I have. Alright, cool. That is this amplifier sorted. Let's get the back case on and move on to something a bit more interesting. The next one I'm going to be working on, guys, is going to be possibly a bit of a deep dive, possibly a bit interesting, so buckle up. I hope you're paying attention. It's going to be interesting, I think. Jimmy, I have two of the double surround Vegas. They are the most musical subwoofer ever, subjectively. I've been offered quite a bit for them. They reproduce classical bass, etc., like no other. Nice. I'll have to check out those, man. If you've got a model number for those, drop it in the live chat. I'll check them out on the online. See if I've ever, because the double surround Vegas. Trying to think in my mind whether I've actually seen those before in person. I might have done. Sam, we ever do a sealed box for comparison on your channel in Boom or Bust? Yeah, man. Hey, if you like, we could do the sealed box today on live. We'll take a look at something to repair just now, and if that doesn't go too well, oh crap! You know what? I forgot to put in the long board screws. Pain in the ass. Yeah, we can have a look at the sealed box live and see what kind of scores it does. But I think it would be good to do it as a video. I think people would want to see it as a video, but. I can edit it later, but it will still be an edit of a live stream, so it won't be very nice. Very nice quality. Or I could do it on live now and then actually film it later as like a proper episode, but. So have you ever seen the GTI Mark II subwoofer? It's probably the best designed sub. Yes, I have, man. They are absolutely beautiful. Beautiful drivers. Yeah, huge fan of those. Okay guys, who's a Rockford Fosgate fan here? Who likes their Rockford stuff? Gonna get some interesting old school Rockford gear out in a minute. Okay, let's have a look. Let's have a look. Where is it? Is it there? No. What are these? Ah, here we go. Okay. Who knows what this is? You'll all know what this is. Oh look. Now that, my friends, is a nice old school piece of kit. However, I have 3 of these. None of them work. And we're going to try and find out why. So let's crack the back off this and take a peek inside. Has anyone ever seen inside one of these before? I've got 2 black ones that don't work either, so it's not just the chrome. Oh, this one's a bit different to the black one. It seems to have, it seems to carry on over to this side here. Yep, I've got all of the controller, I've got the controller, I've also got the balanced input module as well. Oh man. Wait, where's the daughter board for this? Also, look at the state of that. Okay, well it's quite obvious why this one's not working, because there's no daughter board. Oh man, this one's got wet. This ain't dusty, this is corroded. This is moist damaged city. All of that junk. It's pretty bad on these headers as well here. These are pretty corroded. These capacitors. Man, this is looking pretty bad. Okay, well let me get another one of these out, because this one doesn't have its daughter board for some reason, which I assume that it needs to have to function. I have no idea about these things, by the way, guys. I've never worked on one of these before, so we're gonna look at these, learn them together. I've never even used one before, so let me grab one of the other ones, see if that's got its daughter board. Alright, there's the wire for the controller. There's the top for one of the black ones. Alright, here we go. I already took apart one of the black ones the other day, but I didn't look at it really, I just kind of took it apart just to see what was inside. So yeah, this is what the top board is supposed to be. The little daughter board. This is the main board. So this one doesn't seem to have as bad, like this one's not got any water damage, you know, not got any corrosion as a result of water like the other one has. So I think we power this up and see what it's doing. It's kind of annoying that the daughter board sits over here, because it prevents me from really accessing most of the circuit while that's in place. But I think we're just going to have to roll with it. Oh, someone said this is the, if it has two LED bands, that's the 28 band EQ add-on. Not needed. Oh right, okay. So this daughter board thing, you're saying, is not a required part to be fitted. Oh yeah, this does look like an EQ. Has markings on it for the different frequency ranges. So if that's not a requirement, that's cool. Thing is though, is that these cases, right? These cases have the window in them for the EQ. to show, you know, this bars to show through. So without that, are you telling me that it just has this window that just shows nothing, like that? So if you didn't get the add-on, would it just sit like that with a window in it that just shows nothing? Because if so, fair play, fair enough, but seems a bit weird. If you had no add-on, you had no display. Wow, fair enough. Fair enough. It do be like that. Right, let's get some power connected then, gents. Okay, so from memory, this one was drawing quite a lot of current at idle. Now this isn't an amplifier, this is just a processor. From what I understand, these should draw no more than a few milliamps, like a few tenths of an amp at idle. And this one from memory was drawing about 2 amps, which is a lot of current from a device like this. So I reckon something is shorted and leaking badly inside here. So we're going to take the thermal imaging camera first. Yes, these are customer things. They are indeed. So let's have a peek and see what's getting really hot on this one. Power it up. Oh, okay. This one's now drawing only 0.6 amps. This one was definitely drawing 2 amps before, so maybe the faulty component is on here. Interesting. Maybe these fail quite often. Actually, I don't have the controller connected, so it could have been that. Let's get the controller connected. I have 3 controllers. No, I have 2 controllers, I think. 2 or 3? Yep. I've got 2 controllers. One of them is in better condition than the other. There we go. This is the one that's in fair condition. So let's plug that in. Oh no, that's the wrong cable. That is the cable for the balanced input mode. I need the phone connector cable thing. Here's down here. There we go. So that goes in there. That goes in there. Okay, it's powered up again. Right, now we have 1 amp worth of idle current draw. Cool, cool, cool. Okay, let's just see if anything is getting hot. 1 amp seems a little high. Okay, there's definitely something over this side that's kind of getting a bit toasty. UR3 and UR4. LM34, LM340T5, LM7905. Okay, so we've got some regulators over there that are clamped down to the board and getting somewhat quite warm. We've got one part over here, looks like it might be a resistor that's getting kind of hot. Over here. Something over here is getting to 50 degrees. Now let's see if I can pinpoint. That looks like this blue resistor. That's nothing too out of the ordinary. A big resistor like that's probably dropping voltage across it, therefore it runs hot. Let's see what else on the board over here might be running a bit warm, if anything. Okay, nothing looking too bad at the moment, apart from this. There's definitely some big heat being generated over here, 47 degrees over here. Now, is that the LM7905 or is it the 340T? I would say that's the 340. Now, what voltages are on those? Got 50 plus 15, ground, and 5. Okay, interesting. Negative 14, negative 5. Okay, looks like the LM340T5 is actually a 5 volt positive regulator, and that is getting pretty hot. Well, it's either this one or it's the negative one that's getting pretty hot, but one of these two. We've got 15 volt regulators here. Yep, they're doing the job. So we have plus minus 15 volts. That's good. We have our plus minus 15. We have our plus minus 5. A drop of isopropyl will tell you that's a good idea. Yep, do that quite often. So let's spray some isopropyl on these and see which one evaporates from quickest. Okay, yeah, it looks like both of them, to be fair, it evaporates relatively quickly from. I'd say, if anything, the positive 5 volt reg is evaporating a bit quicker. So I was expecting to see some hot spots on these kind of op amps and stuff over, you know, these chips over here. Something's drawing a fair bit of current, but it's not drawing as much as when I had this board in. So I might put this daughter board back in and see what happens. This resistor is now running at 60 degrees. I want to see what that resistor is doing. What's that dropping? We have a little power supply section over here that's probably switching. So that is taking 11 volts down to ground by the looks of it. Got our fuse there. Okay, cool. Doesn't seem to be getting as hot as it was with this daughter board fitted. So let's fit this board and see if that increases the current draw considerably. And yes, yeah, a regulator running hot to give you 5 volts is perfectly normal. But because obviously I've got 3 of these, and this one, compared to the other 2, was running considerably hotter. So although the regulators do run hot normally anyway, this one seems to be running hotter than the others for some reason. Remove these screws here for a second. Okay, let's see what the current draw is now. Wow, 1.6. So we added a whole 0.6 amps worth of idle current draw. And you can see the meters here are constantly illuminated a little bit, which is, don't think that's supposed to happen. So let's use our thermal imager again, have a little probe. So now that we've got this top board fitted, we are drawing a considerable amount more current. These regulators are getting pretty toasty. Let's see if there's anything on the EQ board that gets hot. It's hard to tell. Oh yes, we have some things on the EQ board that are getting hot. And what I'll probably have to do is I'll probably have to just quickly remove it and flip it over to actually see the heat. So off, remove, flip, and temperature probe. Okay, so all of the op amps are heating, but not excessively. It looks pretty okay to me. But yeah, this one's definitely drawing a bunch more current than the other ones that I've got here. Anyway, let's throw some signal through this and see if we can figure out why it's not working. See if we can figure out where the signal gets lost or what it's doing. So, input. We're going to go input A, which is right next to, it's the one closest to the power LED. So we're going to go input A over this side. And then we're going to have a look at what's coming out of the RCAs. Which we can do just by probing the backs of these, because they are the positive on the back of the output there. Cool, cool. So let's turn on the signal gen. We're going to give it 330 Hertz, just a sort of mid-bass kind of frequency there. So we're going to confirm that we have signal going in. Okay, so there's our signal going in. So let's see if we can just sort of work out where that's coming from. Now if we look at the controller here, we're going to go preamp, source A, that's correct. We want source A connected. Go back. Fader is balanced in the middle for balance and fader, cool, cool. Don't think we want tone. EQ, it doesn't really matter what that's set to. Crossover, we just want to make sure that it's all within a range to play our frequency. So I'm actually going to increase the frequency from 330 up a little bit to about 750. So yeah, we'll definitely be playing it on the low pass mode here, because that's above our low pass set. Oh sorry, no, low pass, no, it's this down, isn't it? So okay, let's go down to about 500. So yeah, we should still see this frequency come through if we play sort of 400. So we've got our low pass set to just about 550. Band pass back. Yep, we're within range for our 400 Hertz to come through. High pass back. Yeah, pretty much we should still get some signal coming through on that one. Same for front. And same for front. Yep, we should get signal from all of these different, like, you know, low pass, band pass, high pass modes. With our 400 Hertz that we've got going in. That's fine. Setup, levels, manual, A, left, right. This is our level 135. Yeah, that's just changing the level. So, as far as I'm concerned, I've never used one of these before, but as far as I'm concerned, we should now have signal on the RCA outputs, but we don't. Nothing on that one, nothing on that one, nothing there, nothing. We've got a bit of DC, got negative volt, we've got negative 0.9 volts on this RCA. How about on the ring? Nothing on the ring, so we've got a bit of negative DC on this one. Nothing on that one, nothing on that one. Nothing, 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 nothing. So we've got absolutely no output at all on any of the RCAs, and on the low pass output we've got about negative 0.9 volts worth of DC. If I turn the signal up and down, just pulse the signal, it doesn't affect the sine wave here on the scope at all. We don't get any bumps, any pulses, don't get any DC changing, anything like that. So I guess I need to follow the input signal through this board and see where it gets lost. So the first things I can really see, you've got a bunch of op amps over here. I've never worked on one of these before, so I don't really know what I'm doing. A schematic might be quite useful actually. I might go hunting for a schematic some point soon. But let's just see if we can see a sine wave at any of these points. Here we go. This has got a bunch of DC on it. That's probably not anything to do with our signal necessarily. Got a bunch of DC all on there. Sort of 9 volts. There's some PWM there. That's some PWM. That's probably something to do with the processor. So okay, that's not going to be our analog audio signal. Let's have a look at these op amps here. Let's see if we can find our audio signal. And this is also a good thing to check for DC. You don't want to see any DC on any of these op amps because that suggests that one of them is leaking. Ah, there we go. There's our signal. So I found it. So this op amp up here has our audio signal on it on pins 2, 3, and oh no, what's that? 1, 2, 3, 4. On pins 5, 6, and 7. Okay, great. So our audio signal is at least getting to part of the preamp board over here, this side. We've got our audio signal again there. Okay, cool. So where does it go after that? What are these chips here? No idea what these ones are. This is pretty much obsolete, yeah. The only really use case I can see for this is just for like a retro build. Okay, what's this chip doing then? Let's just see if we've got any analog audio inputs on it anywhere. Got possibly data, PWM. Got some DC. Ah, there we go. We have audio on one of the pins of this chip. This says Dallas on it. DS1267S. So we have audio signal in, and we have some kind of like data, some kind of PWM style waveforms, which could be related to our signal. So let's just zoom in a little bit on the data here. Oh bloody hell, it's fast. It's rapid. Whatever this frequency is, my scope can't actually read it at all. It's so fast. Okay, not to worry. But at least I'm kind of pleased to see that we've got audio going in there to whatever this is. So I assume that this is the processor. I doubt this is going to have any analog audio on it, but we can check that it has VCC. So 5 volts on there. So far this chip just seems to have a bunch of DC on it. I was expecting to see some kind of data. Maybe the thing that dies in these is this processor. There's like barely anything on any of its pins. So this chip just has some random DC voltages on it. Doesn't have any clock signal or anything like that, but I haven't actually googled to see what this is, so it might not be a processor of any kind. It might just not need any of those things on it at all. Let's move over to the Dallas op amps, probably these DS12 things on the other side. Let's see if we can see any audio waveforms over here on any of these. I imagine we probably won't see any because we've not got any output on any of the RCAs. We have supply voltages, but that's about it. Yep, nothing on that one. Nothing on this one. Nothing on this one. So I would say, I mean, it's a bit strange. I would have said that this should have some kind of, I don't know, data or something going on there. Let's have a look at the live chat. Okay, Dallas chip is a digital potentiometer. Okay, great, good to know. Thanks for that. Digital potentiometer. So should the Dallas chip have a analog input and an analog output, or is it giving some kind of data output from that? Because I only saw the sine wave going in. I didn't see it coming back out of it. Let's see what you guys are saying. Jason, no worries, man. The data would be present when you change settings. Ah, makes sense. Okay. Digital pots only have digital data when they change settings. So, if these are digital potentiometers, then I should be getting analog audio in and analog audio out, I would assume. So let's bring up a data sheet of these digital potentiometers. So, we have DS1267S. Let's have a look. Okay, here we go. Dallas Semiconductor. So, pin assignment. What version do we have here? How many pins are there? 1, 2, 3, 4, 5, 6, 7. We have a 16 pin, so that's this top one. So, my audio input to this digital potentiometer was on pin. Right, let's just go through the pins. So pin 1, VB. Yes, we have negative voltage on that. Pin 2, not connected. There's nothing on there anyway. Pin 3, H1. So we have audio input to H1, which I assume is high one. And L1, we have nothing. W1, we have some very, very high frequency like wave that I can't even read with the scope. Reset, we have nothing. Clock, CLK, we have nothing really. Ground, we have nothing. DQ, pin number 9, we have nothing. Pin 10, C out, we have nothing. L0, we have nothing. H0, we have nothing. HO, H out, we have nothing. WO, we have some very high frequency noise. Pin 14, S out, we have high frequency noise. NC15, and 16 we have positive voltage. So yeah, we have input to H1. We don't have anything on CLK, whether that's correct or not I don't know. We don't have anything on any of these, H0, L0, we don't have anything on C out or S out. Does it tell me what those are supposed to mean? Pin descriptions. Okay, L1, so we've got audio input on H1. H1 is high end of resistor, so we've got audio input on high end of resistor. Then we've got W, which is the wiper terminal of the resistor. So that's like the potentiometer, right? So VB, substrate bias voltage, VCC plus 5 volt supply. Stacked configured output, reset, DQ'd, serial data port, COK, serial port clock input. There's nothing on that. Don't know whether there should be or not, but there's nothing on that. C out, cascade port output. No idea what the heck that means. But I'm assuming that we should have some audio output on either L or W, 0 or 1, depending on how the potentiometer has been configured. Yeah, so we don't have any output from that. And I'm wondering whether that's because the clock input is missing, although I assume that would only be used if the serial port input is being used, which it might not be. Let's have a look. Does it say anything about that? Description. Operation. Communication and control are accomplished through a 3-wire serial port interface that drives the internal logic. Control logic. The 3-wire serial interface consists of input signals reset, COK, and DQ. Chip is selected when, okay, the reset control is used to enable the 3-wire serial port operation of this device. The chip is selected when reset is high. Reset must be high to begin any communication. Okay, that could probably be something to do with the input signal when I adjust it on the controller, perhaps. The COK signal input is used to provide timing synchronization for data input and output. The DQ signal line is used to transmit the potentiometer wiper settings and the stack select bit configuration. Okay, I've got a feeling that we should have some kind of frequency on CLK at all times, but I'm going to probe that while I change a setting. So let's go back to the camera for a minute. Let's zoom right in on this potentiometer, and so we want to be probing pin. Oh, we've got a 16 pin. So pin 7. So pin 7 is what was it? This one right here. 1, 2, 3, 4, 5, 6, 7. So that's the CLK pin. So let's see whether we get any clock signal on there when we change a setting on the controller. So I've got the controller right here. I'm going to go ahead and change a setting. I'm going to change the input sensitivity perhaps and see if that gives us some kind of clock. Oh, hang on, there we go. We do have some clock during power up. So if I power this up, yep, see there's some clock signal there when I power up. So if I go to the settings now on here, setup, and go to levels and manual, A, and adjust the level. There we go, look. As I adjust the level, we actually do get some clock signal there. So that's working okay. The only thing we don't seem to have is any output. I'm going to really increase the level. I'm going to go all the way up to maximum. There we go. It's maximum output now from the input. And we know that that was adjusting this one here because that clock thing appeared when we adjusted it. So we've still got audio input on pin 3. So I should get audio output on either 4, 5. Yeah, I should get audio output on either 4 or 5 because that is the low side of the resistor, or the wiper? Nope, nothing there. And there's like some noise on the wiper, I think it is. So I wonder whether it's just these digital potentiometers are bad. Should we check the other one as well? Let's have a look at this other one down here. Is this for left and right, or is this for A and B input? Okay, I'm going to go ahead and select input B now, and see whether we get any audio signal on pin 3 of this one, because this is again a digital potentiometer, right? So let's go back to, on the controller, let's go to preamp source, and I'm going to go to B. So nope, didn't get anything on there. How about the other side? Any audio input on any of these? Nope. So I'm not sure what this potentiometer is meant to be connected to, but I'm not getting any audio input to that one. Let's go back to input A, which is this one up here. Preamp source A. Okay, well that's weird. Now I don't have any input signal to that pin at all, anywhere. Eh? I was getting audio input on pin 3 earlier, wasn't I? Why don't I have that anymore? Oh, there we go. I think I just wasn't zoomed. I think I was just zoomed in too far on the scope. Bloody hell. Okay, right. So there's audio input there. If I go up to this top one, maybe it appears on the other side. There we go. So we've got audio there on that pin. So left and right. So now if I go to input B over here. There we go. Now we've got audio input to this one. So that does work. So do I get any audio output? No, see, I'm still not getting any audio output. Although there's something that does output. Look, if I probe the, I think it's the wiper pin, this one, look at the scope. When I remove it, it does change. But it's not actually the audio that I need. You know? Though weirdly, when I only plug the RCA half in, look, when I only plug the RCA half in, I do kind of get audio output from this. But I think it's, yeah, it's on all of the pins, isn't it? So that's not actually true. Yeah, maybe this is maybe the issue is with these then. But how, like, what are the chances that they both died? I'm a bit confused how they would both randomly die. So the voltage regulators are sitting at 80 degrees Celsius, very, very hot. And some of the op amps here are sitting at about 42 degrees. A couple of the op amps on the output side are getting a little bit warm, sort of 36 degrees. Yeah, I think 80 degrees Celsius is too hot. That's way too hot. Like, they shouldn't be getting that hot. Like, it's proper cooking. So something is drawing too much current from those voltage regs. But the only thing I can see on the board that's getting, like, you know, pretty hot is you got these op amps here, but they're not leaking. They're not doing anything bad. Not got any DC on any of their output pins, and they're working as intended. Let's see if there's any audio waveforms on this daughter on the pins for this daughter board. Nah. No, so I'm not too sure. Let's have a look at another one. So we've got 3 of these. Now the chances of all 3 of them having exactly the same fault are pretty low, right? So I'm not going to look at the one that was chrome because that one was like water damaged like heck. So let's have a look at the other black one, which is looking pretty dirty, but might be a bit clean inside. Let's have a look. This is the other black one that I've got. So let's crack this open, see what's inside. See if it exhibits similar behaviour to this one that we just looked at, or different. Oh, Mr. says that the volume control is actually on a different place on the controller. I hadn't actually noticed that. Yeah, let's plug this back in real quick, just to see if I was being a stupid dum-dum. And let's just see whether all I needed to do was increase the volume on here. Looks like there's a volume here with mute in the middle. Like, don't really know what this controller does at all, but let's just plug this back in and see whether increasing or decreasing the volume on this makes any difference. Oh, the volume was already at max. Yeah, the volume was already up at maximum here, unfortunately. The thing that I didn't actually look at is why I've got negative 15 volts. Sorry, negative 1.5 volts on the low pass output. I hadn't looked at that, because that's clearly a sign of an issue. There we go, we've got negative 1.2 volts on this op amp, this TL072C. Probably shouldn't be there. We've got positive 9 volts on that one, positive 6 on there. Yeah, this op amp doesn't seem right, or there's something not right over here. There's a bunch of DC going on. But even if there's issues with the op amps over this side, I wouldn't have thought that would influence the signal on the other side of the board, right? But yeah, there's definitely some issues over here. We've got 1.2 volts negative on a couple of these op amps over here. Positive DC. So there's definitely something funky over there. Yeah, this isn't an amplifier, guys, it's a processor. It is ancient, it's from like 1995 or something like that. This one's got the daughter board as well. Okay, this one I want to say looks relatively clean-ish inside. Doesn't look water damaged like the other one, so that's good to see. Okay, let's get this one powered up. This is a different one again. Alright, let's power this one up then, see what this one's doing. See, this one only draws 0.3 of an amp, right? Tell me that there ain't something wrong with that other one. The other one was like running at 1 amp. This one's drawing 0.3 0.3. So something is shorted in the other one. This one, let's just check all the auxiliary voltages are present on this one. Oh, they're not. I'll tell you why this one only draws 0.3. Because it's not actually doing anything. Okay, right. So the power supply is not working in this one then, by the looks of it. I'm not actually sure how the power supply section in these works. So I might need to consult the other one that we were just using to see how the power supply works. It's not any standard kind of TL494 stuff, but we've clearly... What the heck? What is that? Chassis, A ground, D ground, and ground. Yeah, this one's not doing anything power supply wise. Well, that's a good sign. That means that if we fix whatever the issue is with the power supply on this, we might have a working one that we can use as reference for the other one. Because power supply faults are going to be probably a bit easier to sort out than whatever the heck is wrong with the other one. Unless it's the processor that controls the power supply here. So, well, we've got a transformer. So we know that we should have some switching MOSFETs here. I suspect these are the MOSFETs and these should be switching. Got 2 FETs there and a diode. So let's just bring up that one that was getting hot and let's compare what the power supply is doing on this one. So this is the one that was getting hot. So we know the power supply is working on this one. So let's see. So we've got our power supply here, and yep, there we go. So this has a normal sort of power supply switching. The gate drive seems to pull low though for some interesting reason. So the gate drive pulls low. Look at that. It's like interesting. They must be P-channel FETs. Yeah, this must be P-channel FETs in the power supply. Ugh, that's weird as hell, man. These are old. So that's a normal power supply. So what's driving the power supply FETs here? We're just going to have to trace back from the MOSFET gate, I guess, and see what's driving the power supply FETs. Just turn that off. So the gate is going to be the one that's not connected to ground. So yeah, this is the gate. Okay, so where the heck does that go? I might have to pull this out of the case to follow it. Oh, there we go. I just, by luck of the draw, found, I think, where it seems to go. I've got a 220 there. And, wait, what? This resistor? No, that resistor had nothing on it. What are you talking about? Ah! Oh man, this looks like some rudimentary way of oscillating the power supply circuit. We've got a diode here, D5, with some pulses on it. This little transistor, what is this, VR5? Is that a transistor? That's an LM7805. So we've got 5 volts on that, coming in from 12, okay. We've got a couple of diodes down here. So it looks like the PWM is on this D5 here. Where does that come from? Does that come from any of these circuits over here, like this HXHCO4? Probably not. I think that's something to do with the audio. Alright, so there's D5, that has the PWM on it, that's going to end up driving the power supply. There's our rectifiers for the main rails that this thing uses. So let's power it off, and let's go off D5 here. Let's see where that's connected to. It's apparently connected to this voltage reg, but it's not. It must be connected through the transformer. Yeah, it's not actually connected, it's just got a DC connection to it. Maybe this transformer is doing more than meets the eye. Maybe this transformer is like building up some kind of oscillation. Okay, let's turn our attention back to the one that doesn't do anything with the power supply. Let's just compare with what we've just seen. Right, this resistor is 326 ohms, it's supposed to be, that big blue resistor. Could be a common failure point. Ah, see on this one, this resistor is 670 ohms. So that's a possibility. That's a possible bad part, okay. Let's compare that. Let's compare that to the chrome one here that's a little bit water damaged. Although you can't necessarily trust anything on this one because this one looks jank. Okay, this one is 679 as well. So I think that this resistor is supposed to have a resistance of about 600 ohms across it. This one is correct, and this one that has a 300 ohm resistance across it is identifying that there's a problem somewhere, which is why this one's getting so hot. But we'll look at that one later. I want to get the power supply of this one up and running first. Let's check across this diode, D5. Now that has a low resistance of probably what looks like to be about 20 ohms. 22 ohms across that that diode. Okay, let's see what it is on the other three that we've got, the other two. Now, obviously a diode shouldn't be that short, so yeah, this diode is reading open one way round, and the other way round it reads still open. Oh no, that's because I got 200 set on the multimeter. Let's read that again. So this diode reads 900 one way round, and the other way around it reads 434. Okay, so clearly that shouldn't be a short circuit. That shouldn't be 22 ohms. So that's a problem. What is it on this skanky one? 400 and something one way round, and it's completely open the other. Oh no, got 1126 that way round. Okay, cool. So this diode probably is screwed. So let's take this out of the case, remove the diode, and try and find out exactly what the hell it is, because we're going to have to replace it with something that probably isn't in manufacturing anymore. We're probably not going to be able to get that exact diode anymore, so we can find it out. I got the schematics up. Can you tell me the resistor number so I can check for you? Yo, Mr. EE100, thank you very much, that's awesome. So the resistor is R178 is the resistor. And the diode, if you can get a model for the diode, is D5. So R178 and D5 are the areas we're currently looking at the moment. 330 ohm. Interesting. That's really interesting. So why on these other two does it read much higher? So in this one we've got blue-grey, maybe blue-grey, brown, gold. On this one it is unreadable because it's corroded, and this one it is hey, mister, the resistor values are different. Look at this. Between these two boards, this one appears to be orange, brown, gold. And this one is blue, beige, brown, gold. So the resistors are actually different in their markings and in their values from factory by the looks of it. Yep, that's the one that's reading low at like 300 and something, and that's the one that's reading higher at about 600 and something. So maybe there were some different revisions that were going on. That makes it even more of a pain in the ass. Can you see a version on the bottom right, the way you have it? Bottom right. Symmetry EPX2. It doesn't seem to say like a version. This is all I've got. See if that means anything to you. I'm just getting the board out of the case now so we can actually replace that diode. It seems to have failed. Bunch of screws on this RCA. The Boom or Bust series is awesome. Thanks very much, Rick, and appreciate that. And cool, Attic, thank you very much as well. I'm glad you guys are enjoying Boom or Bust. It's pretty entertaining to film. Oh, can I get you guys' opinions? Can I get your opinions? So with Boom or Bust, obviously I test with door open and door closed. How much do you value the door closed? Because I wasn't originally going to do a door closed DB test, but I figured that some people might want to have it there because it sort of represents the DB drag testing method, the old school, the old testing method. But it seems a bit inconsistent. So I'm thinking of just scrapping the door closed test. But does anyone, think that that's a bad idea? Does anyone really like the door closed test? I honestly don't think that it rings true. I think that there's too much variance in how the door closed test gives its results. But I'd love to hear your thoughts on that. I'd love to hear your thoughts on whether you value it or whether you don't really care about the door closed test. All say 330 ohms. That's really interesting, isn't it? So two of them that I have here have higher value resistors fitted. It's really weird. Oh man, there's some freaking spiders and shit in this one. Oh man. Bro. What's worse as well is I just got done playing Hogwarts Legacy and there's some scary spider moments in that game. Right. Alright, let's remove that diode then, shall we? Where is it? There it is. Let's grab that one. It's going to be shorter of the two. That one there. It's fine, man. This board was made in the USA. It can handle a light, very, very light scraping from my blunt tweezers without any issue at all. Don't you worry about that. Okay, so hopefully the short has disappeared. If not, then the issue will be somewhere else on the board. Oh no, the issue's not the diode, it's somewhere else on the board. All right. Okay, where else could it be? It could be the power supply FETs, to be fair, because we have a short between gate and source on there. So it could be the power supply FETs themselves. Yeah, let's remove these power supply FETs, shall we? And in order to do so, I think I've got to remove the heat sinks as well. As you can tell by the discoloration on the board here, look at the colour of the PCB here. This has got hot. Yeah, this is like ran pretty hot at some point in its life. So I wonder whether there's actually some shorted components on the board that the power supply runs that cause the power supply FETs to get super hot and then fail. Because why would the power supply FETs of a DSP board run hot like that, you know? I bet it smells like solder in that whole house. Interestingly, it doesn't. I don't like how the solder smells. No, it's not for me. Okay, so the two power supply FETs are out. Let's see whether the short has disappeared now. Yeah, okay, so the issue then was the FETs. Nice and easy, we can sort that out. So there we go, there's the two FETs, wait for them to cool down. These are some old ass FETs. If you ever wanted to see some vintage silicon, there it is, my friend. These are Morocco. What is the model? BD911, I think. Oh wait, these might not even be MOSFETs, they might be BJTs. In that case, I can't put MOSFETs in place, especially, well, the gate drive, it drives them low. So, BD911, let's have a look. What is that? Here we go. Complementary silicon power transistors. Muy bien. Me encanta. So this is, yeah, literally it's not even a MOSFET. Wasn't even MOSFETs running the power supply. It was a couple of NPNs. Which is weird. Hang on. Yeah, wait. Really? I guess. Fine, alright. Yeah, a couple of NPNs then, running the power supply. Base current is 5 amps. I'm sure that I've got something here that I can use instead. I am not accustomed to using BJTs in the power supply section, so I don't really have an instantaneous go-to. Let's just see what I got. I think I could probably get away with running some PNP MOSFETs though, hey? So these are NPN transistors. The gate drive goes from 0 volts to -5 to drive the BJT. Now obviously if I stick a 3205 in there or something similar to that, like an N-channel FET, that needs the gate drive to be above ground for that to actually turn on, but a P-channel MOSFET doesn't. So I could use a couple of, 12 P20s. Thanks for the $2. Slightly happy. Appreciate that, man. Thank you very much. Oh, take the ones out of the corroded board. That's not a bad idea. I could. I reckon some 20. Oh, yeah, it depends if the voltage is high enough. But all right, let's just see what transistors I've got. All right, what about these? What about these? These are A940s. A940, what's that? It's the wrong type. SC 2073. On average, it takes between 12 and 24 hours to print the boom or bust boxes. Oh heck, I was going to use one of these, but the base current is nowhere near high enough. Alright, screw it. I'm going to chuck in some 12P20s and just see what they do. You know, screw it. See what 12P20 does in place here. I need to find them though first before I do that. Actually, how about a BD139? I know it's a smaller package, but would that work? Connector current now, it's not quite enough. Well, it shouldn't be more than like 5 amps. I reckon some BD139s would actually work in the power supply here. Like clamped to the heatsink. If the 12P20s don't work, I'll try some BD139s just for jokes and see if they work and see how hot they get. Right, there's one 12P20 and here's another 12P20. Right, let's see what this does. Season 1 of Boom or Bust should be going for some time yet. Don't worry, you've got time. Right, so there's a couple of things here. Okay, this could actually I need to replace the diode. This could either not work because it doesn't like the 12p20s, but it could also not work because there's something else damaged on the board that caused those to fail in the first place. And but that might throw us off. Like, it might be difficult to tell whether they're not working because they're the wrong type of part, or whether it's not working because there's another issue on the board that caused that to fail, you know? Uh, 24 hours with the bigger nozzle, yeah. I'm using the 0.6 nozzle at all times now. I'm not using the 0.4 anymore. All right, let's see what happens then with these 12p20s. I don't have very high hopes, but I'm kind of curious to see what it does. And these power wires are doing me a bit of a hecking. Alright. Okay, so I think the fuse just burnt out. Did anyone see that? I saw a little bit of light. Yeah, the fuse just burnt out. So I guess it doesn't like the 12p20s. No worries, no worries. Let's get the fuse from the donor board here. Alright, let's put some BD139s in, because they're pretty high current. I don't have any old donor boards. No, I don't think so. I asked Hexie about submitting a design for Boom or Bust in his Patreon, and he said pass. Yeah, I thought he would, to be honest. But the only thing that I worry about is I worry that Pete has got the wrong idea about the series. I imagine he probably doesn't have time to watch it. He probably hasn't watched an episode of it. So he might be assuming, just based on, you know, the thumbnails and the pictures you can see, that the series is using these small boxes to play actual low frequencies. And the reason I think that is because I think someone said that he mentioned that it doesn't scale properly, and he would only say that if he assumed that the boxes that I was printing were going to be asked to play actual low frequencies, in which case, yes, he's absolutely correct. It doesn't scale. You can't like scale down a you know, a 30 hertz transmission line and expect it to play 30 hertz when it's in its miniature size. It doesn't work like that. The same case for Helmholtz mode boxes and stuff. But I worry that he doesn't realise that it's actually the frequencies that are scaled as well, meaning that it does scale perfectly. Because if that was the case, he might then be interested in submitting one. But maybe he wouldn't, I don't know. So I'm just dropping some NPNs, some BD139s, just temporarily in place, just to see what happens. I think I understand actually why the P-channel FETs didn't work, because obviously we've got a positive voltage on the drain, so that's just going to go through the diode to source. Duh, I'm a stupid idiot sometimes. Alright, let's see what it does now. I'm going to turn the current down on the power supply, just in case it shorts out straight away again, it doesn't blow the fuse right away. Okay, there we go. Yep, no more excessive current draw initially. Right, cool. Let's power up and see what happens on these power supply FETs. Okay, no, so it's the same. We have nothing there. We don't have any power supply drive still. And I don't know what that might just be, because it needs the original parts in place. Like it might be doing some kind of weird flyback thing, you know, where it's using the original parts specifications to kind of cause some kind of oscillation to occur, you know, something like that. Because I'm not entirely sure where the PWM originates from. It doesn't seem to be any chip that generates it. Seems to just be something to do with the transformer winds and a diode and a capacitor or something along those lines. Yeah, Q2 seems okay. That's doing the same as what it was on the other board that's working. I sent an email with the question about the cabin dimensions. Oh, sorry, I probably didn't see that one. Yeah, the cabin dimensions, I'm happy to give them out. They're actually in the dock, I think. The dimensions of the test cabin are already in the dock. Unless it maybe unless I just did the width, the length of it. I'll try and find the dimensions of it. I could do a quick rudimental measure now. Where's my tape measure? Right, so we have the test cabin is, make sure you got a pen and paper there, my friend, the Gary-nator. Okay, so obviously we've got the wood thickness to bear into account. The wood thickness is 12 mil. So we've got 12 mil MDF, okay? So 12 mil MDF. So remember to subtract 24 mil from these measurements that I give you. We got 27 on the depth, 27 centimeters, so 270 mil, thereabouts. Or actually, it might be. Oh, sorry, 274. 274 on the depth. The width is 510 mil at the bottom, because obviously it's like a angle. So the bottom is 510. At the top it is 380 mil, and then the height of the actual enclosure, as far as the driver's the thing is concerned, the height is 185 mil. So 185 mil high, 510 along the bottom, 380 along the top, and the depth is 274. There you go. I'm going to do the sealed box, but probably not today. I've spent too long on this this Rockford Fosgate thing. So guys, I think we're going to probably leave it there for now, but I want to obviously find out where the power supply PWM comes from. So with one of our other boards, because we've got 3 here, which is great, one of them at least, the power supply works. So what I can do is, on the one that the power supply works on, I can remove the power supply transistors and then see if a drive wave is present with the transistors removed. If it's not, then I know that there's some kind of feedback thing going on that generates the pulses. But if it is present with the transistors removed, then I can trace it, find out where it's coming from, and then repair this one here. Thanks very much to the schematics link, mister. Do I have 5 volts on the regulator? Let's have a look. Let's have a look. See what we got on the regulator. We got 5 volts on the reg, so that's doing its thing. We do have 5 volts on the reg. We don't actually have any voltage on this diode. So you see on the on the other board that's working, we did have some voltage on the diode, some DC voltage, didn't we, mate? Look, mate, if I just turn this on for a minute, right? I'm not even gonna touch the bloody remote, all right? Oh, I see. We got DC. Got pulses on there. The thing that's making me think that it's some kind of feedback is because when I pulse the remote like this, see how the frequency changes? The frequency gets smaller as the voltage sinks down. So yeah, the frequency of the switching is relative to the input voltage. So it's self-oscillating. Oh yeah, one board is green, the other is blue. That's very true. Look at the difference in the markings here as well. Different markings as well. So, I'm going to call it now. I'm going to go get some dinner. Probably film Boomer Bust with a sealed box this evening. Then I will catch you guys again, probably for another live stream on these. I think these are very interesting repairs, hey? I know it's not an amplifier, but it's pretty interesting, and it's a good old piece of car audio history. How much this is going to cost the customer to get them back up and running again, because there's a lot of diagnosis time here going to be taking place, so who knows, but we'll see if we can get them back up and running for the customer. At least one. You've got 3 here. I'm sure I can make a working one out of 3 dead ones. Might be a fun little project. Catch me next time, later on this week, for some more DSP Rockford repair content. Yeah. And yes, I will start studying these schematics. You betcha, I'm gonna freaking study these schematics this evening. Gonna do that. Yeah, none of the chips are in headers, they're all soldered, unfortunately. The first wait, Mr. says this is the original. Which one's the original? The green one or the blue one? Oh, the D. This top one. This is the original. Okay, that's old as heck then. Yeah. So yeah, see you next time, guys. Hope you have a great rest of the day wherever you are, and hope you have something really tasty to eat. That's really important, man. Make sure you have something tasty to eat. It sucks, doesn't it, man, when you eat something that's like not tasty. It's such a waste.